Yeah, okay. So for this topic, we're going to learn about multiplying and dividing fractions. And if you look at the example, we're multiplying 3/5 by 9/8. Does that make sense?
No. How do you what would you do to start?
Okay, so what do you think you would do to begin this?
Would you make a common denominator?
Actually, for multiplication, you don't need to make a common denominator. You can just multiply the top, which is the numerator, and then the bottom, which is the denominator. So it would be like this: 3 times 9 and 5 times 8.
Okay.
So alright, so if you have 3 times 9, what would that be?
27, right?
Yeah, so you can write 27 on the top. And when you have 5 times 8, what would that be?
40.
Okay, then you write 40 on the bottom. And then you get 27/40ths.
Can you reduce that answer?
It depends. Can you find a number that is divisible into 27 and 40?
Well, 27 isn't divisible by 2, and 40 is not divisible by 3.
It doesn't look like you can reduce that at all, so you would just leave that answer.
Okay.
Okay, so if we do another multiplication problem, how do you think you would do this one based on the previous one?
Would you multiply the numerators and then the denominators?
Exactly, and before you do that, you can actually do cross-canceling, which reduces the numbers and makes your multiplying a little bit easier. So cross-canceling means you can look at 10 and look at 4 and divide them by the same number in order to make them smaller. So what goes into 4 and 10?
Doesn't 4?
10 isn't divisible by 4. What about 2?
Right, 2 works.
Okay, so if you divide 4 by 2, what do you get?
2?
Right, so then you cross 4 out and you write 2. And if you divide 10 by 2, what do you get?
5.
Okay, and now if you look at 12 and 2, what goes into 12 and what goes into 2?
2 does.
Okay, so 12 divided by 2 is?
6.
And 2 divided by 2 is?
1.
Okay, so now you have your new numbers. You have 5 times 1 and 6 times 2. So if I write this line, can you write out what 5 times 1 would be on top?
So that would be 5.
And 6 times 2 would be?
12.
Perfect. And that's basically multiplication. So if we move on to division, we have the fraction 8/6 divided by 5/7. What do you think?
So would you do 8 divided by 5 and then 6 divided by 7?
That's a good try, but we're actually going to switch this division problem into a multiplication problem. That's how you do division with fractions. So the first thing you do is you're going to keep your first term the same. And so below 8/6, you're going to write 8/6 again, because you're going to keep it the same.
Okay.
But rather than dividing, we're multiplying. And we're multiplying the second term, we're multiplying the first term by the second term's reciprocal. Do you know what a reciprocal is?
Is it that number negative?
No, it's actually that number flipped. So instead of 5/7, the reciprocal of that would be 7/5. It would just be it reversed. So on this line, can you write the reciprocal of 5/7? Perfect. And now we have a multiplication problem again, and we just did those up there. So on this line, can you write what you think would be the answer to this?
So first you can reduce this though, right?
Oh,
because
yeah.
2 goes into both.
Right.
So that would be 4, and that would be 3, right?
Yeah.
So then 4 times 7 is 28. And 3 times 5 is 15.
That's good. So before you multiplied, what you did is you reduced this term, 8 over 6, to 4 over 3, because you were able to divide 8 by 2 and 6 by 2. You couldn't reduce 7 over 5 because no like term went into both of them. And then when you multiplied them out, you did 4 times 7 is 28, and 3 times 5 is 15, and you got your answer. Okay, we're going to do the second one now. So if you have 14 over 11 divided by 1/2, can you try and rewrite these two down here to make it a multiplication problem?
Can't you reduce this first though? Because the 14 on top is divisible by 2?
Rather than reducing first, you want to make it a multiplication problem and then possibly reduce it.
Okay. So the first one would stay the same, right?
Right.
And then the reciprocal would be 2 over 1.
Right. And now when you look at it, you can't reduce anything.
Okay.
So now it turns into a multiplication problem. And how would you multiply that?
So 2 times 14 would be 28.
Right.
11 times 1 would be 11.
Perfect. Okay. Now we have our last division problem. 17 over 9 divided by 2. So with this one, we know that 17 over 9 remains the same, so you can write it the same. And when you divide it by 2, what is the reciprocal of 2?
Because it's just a number, isn't the reciprocal just 2?
Not necessarily. 2 is the same thing as saying 2 over 1, because anything divided by 1 is itself. So if you're going to flip that, how would you make it a reciprocal?
Okay, so now it's basically just a fraction, so it would be 1/2.
Exactly. And then if you were going to multiply that out, what would you end up getting?
So 17 times 1 would just be 17.
Right?
And 9 times 2 would be 18.
Exactly. So what we did is we said 17 over 9 stays the same, and then we changed this to a multiplication problem, and the reciprocal of 2 is 1 over 2. And then we multiplied it out. 17 times 1 is 17, and 9 times 2 is 18. Cool?
Yep.
Okay.
That makes sense now.